Okay, so yesterday we did exponential. And just a quick review, exponential, we had 2 key points. One was at what? 0, 1, and the other one was at 1a. Exponential also had an asymptote. Looks like that. Today we're going to do the logarithmic functions, and the logarithmic functions are inverses of the exponential. And we did inverses a very long time ago. Inverses are functions that are symmetric over the y equals x line. Inverses are functions where you take the original function and you just switch the x and y values. You just switch them. So instead of 0, 1, it's going to be at 1, 0. And instead of 1 base, it's going to be at base 1. And instead of y equals 0, the asymptote is at x equals 0. We just switch all the x's and the y's. So today's lesson, we're going to do all the same stuff we did yesterday. We just have one extra step where we just have to switch the x and the y's first. Which should be pretty easy if you did yesterday's lesson. So the key points will always be, what did I just say? The key points will always be 1, 0, A1, or base 1. And the equation of the asymptote, instead of y equals 0, will be x equals 0. But that's before any transformation. And just a reminder, we are working on transformations. We're not working on, can you plug numbers in and graph them? We're working on transformations. So I can make a table for every single one of these and just plug numbers into the equation as is and find the graphs. But that's not what we're learning. We're learning how to take a parent function and transform it. So here our parent function is log base 5 of x. The inverse function would be 5 to the x. That's that first example at the top of the paper. That's the inverse function. So 5 to the x has key points at 0, 1, 1, 5. The log base 5 has key points at 1, 0, 5, 1. So how did I get the log point? I took the inverse and just switched them. Over here, we've got log base 5x plus 3. So what am I going to do? Translate up 3. And then that changes my ordered pairs to 1, 3, 5, 4. Notice how I use the purple ones. I use the log ordered pairs. And I added 3 to the y value because it's going up.
If you're just given like the log base 5x, like and you didn't know the inverse,
It's the base to an exponent. So whatever the base is, just put an exponent there, and that's your inverse. All we need to know for the original key points is the base. We just need to know 0, 1, and then 1 the base.
Oh,
right?
Yeah.
So all we need to know is the little number. Okay? How about the second one? Log base 5 of x plus 5. Now, I know for this one, x plus 5 is in parentheses, so x plus 5 has got to be with the x. The one right above it, no parentheses, it has to be with the y. The parentheses is how you can tell. So x plus 5, we're going where? Translate left 5. So I'm going to take my log key points and just subtract 5 from the x's. Negative 4, 0, and 0, 1. The next one has a negative sign outside of the log. Is that negative sign going to affect the x values or the y values? It's going to affect the y's because it's not next to x. Okay, it's outside the function, it's going to affect the y's. So that would be a reflection in the x-axis. And then my new ordered pairs, we're going to multiply the y values. So 1, 0, 5, negative 1. Let's just do the bottom last one there, log base 5 of negative x. What's that negative going to affect for that last one? It's going to change the x value. So we're going to reflection in the y-axis. And then I'm going to change my x values to negative 1, 0, and negative 5. If you are ready, go find number 7. And we'll go through the whole process.
On the quiz/test, is it going to be set up like this or like homework? Because the homework goes like less.
It'll be like, but, I mean, I could ask you just what is the transformation? Like that might be a question. But if we're doing everything, usually I want to ask you as little as possible. Because when I have to grade it, I have to grade it. It takes me a while. All right, so the first thing that we want to do when we look at this is we want to think about the inverse. So I see log x, but I need to know what the base is so I can think about the inverse. Base is 10. If it's not given, it's 10. So our inverse is going to be like 10 to the x. Is there a transformation on log x? There's not. There's no transformation. And this is in slightly different order than the one you're holding. I must have printed yours, right? I think I changed yours. No, it's in different order. Just a little bit, yeah. Yours makes more sense to me. It makes more sense to do the transformations before you find new points. But I don't know why I didn't fix it on here. All right, so our inverse key points are 0, 1, 1, 10. So our log key points will be just 1, 0, 10, 1. We just switch them. That's the 1. We didn't talk about the asymptote except for that very opening example. We didn't talk about the asymptote yet. If the asymptote for the inverse is y equals 0, then for the log, it's going to be what? X equals 0. When we go over and we graph x equals 0, that is a vertical line. And we graph 1, 0 and 10, 1. And then you have to think, this graph is approaching the asymptote. And these points are going to connect. So you got to figure out that the graph is going to be going closer to the asymptote. It's going to look like that. I would always use that asymptote as how I can graph it. But these are a little bit harder to just plug in extra points. Do growth and decay, I put it on there, but we're not actually doing that for growth for this. That's just for exponential. Domain, the x's, left to right. 0 to infinity, and then the range up and down. Negative infinity, positive infinity. So before, when we were doing exponential, the domain was always all real numbers. Now it's the range, like switches. Questions? You okay? All right, number 8. We've got f of x equals log base of 1/3 to the of x. So we want to first think about our inverse being like the base of 1/3 to the x. So what would our inverse key points be? 0, 1, 1, 1/3. Are there any transformations? No. So that means our key points for the log are 1, 0, 1/3, 1. The equation of the asymptote, there's no transformation, so x equals 0. Get rid of the growth or decay. We're going to graph this at 1, 0, 1/3, 1. And then think that it is getting closer to the asymptote. Think that it is getting closer to the asymptote. Our domain is the x values. So left to right, what's our smallest x? What's our lowest x? What's our most left x? 0 to infinity. And then range is negative infinity, positive infinity.
Why is there no growth of the
I mean, there probably could be, but I would think it would have to apply to the x-axis, not the y-axis. Because we did growth or decay, it was talking about the behavior of the y. Is it growing or is it getting smaller? But since we inversed it, it's now about the x, and we don't usually use it. I copied and pasted like all of those things, and then I didn't think about it, so I just added that in when I should have. All right, next one. What is our base? 2 is the base. So our inverse is 2 to the x. Gives us inverse key points of 0, 1, 1, 2. I kind of left some space though, because now I'm going to do some transformations for this one. What are the transformations? I reflect in the y-axis and translate up to 3. I'm just checking your rigging, paying attention. Actually, I was trying to think if the space of my computer was getting too full, and that's why this thing's writing slow. And then I got distracted. That's what happened. I was going to change colors. That's what I was doing. Okay, so then I have to switch, for my log base, I have to switch these from 0 to 1. And then I have to do my transformations. So we are multiplying the x's by -1. And we are adding 3 to the y's for my transformations. So our key points are going to be -1, 3, and -2, 4. The asymptote of the parent function would be x equals 0. But did I do anything to my x's? I multiplied by -1. So I have to do that to the asymptote also. But it's still 0, right? The only time we'll change our asymptote for logarithm functions is if there's a translate left or right. That's the only time our asymptote will change. So we graphed -1, 3, -2, 4, and remember it gets closer to the asymptote. So it's something like that. The domain is going to go left, -infinity, to right, 0, and then range is everything. Doing all right? You did your homework. This is easy, huh? Okay.
Sorry, so the key points, like, even though they're the inverse of the homework that we just did, they're the key points of the log. Like, that's why they're, sorry.
I'm not following what you're saying. Are you talking about these?
Yeah.
And what about them?
even though, like, for the homework we just did, like, the.
Yeah, just put, yeah.
first.
Yeah, like put the two, so you're going to find your inverse points, then you're going to switch them to find the log points, then you're going to do transformations, and that's what goes on the blank. Okay. Don't worry, we got 3 more to try to go through that same process again. So think about, what is my base? What's my base? What is your base? Not just mine, it's all of ours. What is our base? What is it? 4. So we think 4 to the x, and then we write our key points. 0, 1, 1, 4. Then we log it. Log base for it, that just means switch. Then we transform it. What transformations are we going to have? Reflection of the x-axis. And then what? Translate. Translate right 5. So to my x's, I'm going to add 5. Right? Correct? And to my y's, I'm going to multiply by -1. And then what about the asymptote? So since it was originally at x equals 0, and we added 5 to all the x's, you got to add 5 to that asymptote also, so x equals 5. So we go graph a vertical line at x equals 5. The y value.
Oh.
So since the asymptote is just x equals, you don't need to multiply that one. We graph our points, and we use our asymptote to be able to make this graph look like a logarithm. The domain, left to right. 5 to infinity. And then range is up and down. Negative infinity, positive infinity. Okay, before you do that next one, I was thinking about you. Nah, I won't change it. You guys can just ask me questions in your homework. You have plenty of time. You have plenty of time. All right, next one. What do we got? What base? 2. So we have 0, 1, 1, 2. Then we flip them. We write log base 2, 1, 0, 2, 1. And we translate it, or transform it, I should say. No, this one is translating, though. Translate where? Right 2. And down 3. So to my x's, I'm going to add 2. To my y's, I'm going to take away 3. My asymptote normally would be at x equals 0, but am I doing anything to my x's? Adding 2. So my asymptote is at x equals 2. We grab our points and we think about where's the asymptote, because the graph is getting closer and closer and closer to the asymptote. Domain is left 2 to infinity. Range is negative infinity, positive infinity. You notice that our asymptote kind of has something to do with the domain every time. See if you're picking up on that pattern. All right, last one. Ellen. natural log? Yesterday I talked about the natural number. Anybody remember what the natural number is? Oh, I don't mean approximately. What is it?
E.
E. It was E. So the natural number is E, so the natural log is log base E. But we don't ever write log base E. We write natural log. But just for notes purposes, that is what natural log is. It's log base E. But it's so important it comes up so much that they gave it its own symbol. So when we go to do our original inverse key points, we're doing e to the x for our key points. 0, 1, 1, e. And then we do our log points, our ln x. So we switch them, 1, 0, e, 1. And you all kind of said it already. What's the approximate value for e? 2.718. Well, we're not going to be able to graph 2.718. 2.7. Do we have a transformation? Translate. Left 4. So that means I subtract 4 from my x's. And we get key points at negative 3, 0 and negative 1.31. What about my asymptote? So we got x equals negative 4. We've got negative 3, 0. Got negative 1.31. And then keep in mind, we're getting closer to the asymptote when you connect it. We're getting closer to the asymptote when you connect it. And then the other side is not. So the domain is going to go left to right, negative 4 to infinity. Range is negative infinity to positive infinity. Okay.
What exactly do you want us to write for the first key point? What do you want us to write?
That's not in your homework. That was our, like, this is what you should do first to be able to find the key points. It's just like this. But in your homework, I didn't give you a spot for inverse key points, so that would just be part of your work. Like, just like I didn't make you write out all the transformations, but you obviously need to know them to know what to do. Okay? Yeah.
When you have two transformations that affect the y's,
Yeah.
and one's multiplication, the other's addition, do you just do it like order of operations? Like the
You do
multiplication
order of
first?
operations, yes. Where you might have trouble, though, would be what I was saying at the beginning of the class. I'm going to say it again, so it's recorded, and just in case somebody wasn't paying attention. I'm going to bring it back to when we did trigonometry, but it's the same with log. When we have, I can just make up something that has log instead of sine. If we have some number, then we have our log, and then we have the parenthesis, and we have some stuff. Okay, just made that up. When you go to find your transformations, you can't figure out these transformations as is. You can only do it if this is a 1, which it is not a 1. So what do we have to do to that 2 first? So if you factor it out, this becomes x plus 2 minus 9. And then you can tell, we didn't do any, like, there's none like this in your homework, but this would be a stretch. We didn't do any stretches, but this would be a stretch. And then this would be translating which way? To the left for 2. But there is one in your homework that you have to do this for, but it's not a stretch that you have to worry about. You'll see. Okay? It's just it's up even. You should be able to finish it, no problem.
Stretch. What do you multiply the x values or y values?
Well, if it's next to the x, like it was next to the x, you'd multiply the x's but by the opposite, like inverse. You'd multiply the x's by